Hi guys, today we're continuing with our chapter 5 notes, and we are going to be talking about nth roots and rational exponents today. So before we begin, we should probably talk about what an nth root is. N is going to be any number. So it could be like the 4th root, the 5th root, the 6th root, the cube root, right? Root is a radical, which is literally that simple. Rational is just another way to say fraction. It's actually any whole number over any other whole number. So it might not show up as a fraction, but 3 is still rational because 3 is 3 over 1. So let's talk about this core concept of a rational exponent. The nth root of a, written like this, and this is where like that line that I always draw on my radicals comes into play. You want your n, which is your index, to be clearly an index versus like if you accidentally do this. Do you see how my 2's like starting to move out and I have an x? Well, then the question is that x squared square root of 5? Or is that x times, well, in this case, it would be the same. Let's do a 3. Cube root of 5. Do you guys see how like those two things are very different? Right? So this tends to be now a little wishy-washy, and you want to be clear by making it very clear when you write that. We can also represent this nth root as a rational exponent, which means we have a whole number base, or a number base I should say, to the 1 over n power. This n and this n are the same. They're the index. And what that means, it tells us like how many groups we're looking at, right? Square root is like 5 times 5. If this was a cube root, we'd be looking for 5 times 5 times 5, 3 of them. The base is always the same here as the radicand, and then this 5 and this 5, these are just numbers that are getting multiplied in front. Okay, so if you remember from yesterday what we were doing when we expanded it, this is just 5 by itself times whatever comes after. One thing you also need to know is that if there is no index, if it's not shown and you see this, we know that's a square root. Please remember that a square root has an index of 2 because squared is 2. Okay? So this is invisible. Oops. Invisible index. So what's the purpose of nth roots and rational exponents? Well, the reason we need them is because we are going to use them to solve an equation. So let's talk about some inverse operations. You know that addition is the opposite of subtraction, and multiplication is the opposite of division. Well, what's the inverse of an x squared? We know that's a square root, which we now know you can write it as the same thing with a 2 there, right? That means this one must be a root with a 3 for an index. This is called a cube root. If we have a 4 as an index, that's a 4th root. We can have 5, 6, which means no matter what number I use, this can be n. Okay, so the issue with this root is that it's very intuitive. We have square roots and it makes sense to move our way up, right? To cancel out x to the 6th power with a 6th root. The problem is that graphing calculators often don't have this button clearly, or at least not in the basic graphing calculator, let alone a scientific calculator, right? One of those like more simple calculators. So how do we circumvent that? Well, there's another notation, and we can use fraction exponents instead. So if I have x squared, the inverse is to the 1/2. And let's talk about y up here. So if I have x squared, and I take that to the 1/2 power, we know from our exponent rules, I'm going to pull this out real quick, that if we have x to the third power 2 times, it's like saying x to the third times x to the third. That's 3 plus 3, which is the same as 3 times 2, which is x to the 3 plus 3, which is okay when there's only 2 groups. What if I had 5 groups? It'd be 3 plus 3 plus 3 5 times over and over, which is the same as x to the 3 times 2. Okay, so I don't want you to think of it this way. Let's think of it now. 3 times 2 is much faster, which is x to the 6th. Well, if I'm going to multiply these two, I will have x squared times 1/2. Well, 2 halves, which is 2 times 1/2, is the same as 1. So do you see how like a squared cancels out with a 1/2? So those two cancel out and you're left with x. What cancels out with x to the third power? That's x to the 1/3 power. X to the 1/4 to the 1/5 and x to the 1/6, which means over here it can be x to the any number under 1. So let's summarize real quick. We can cancel out a number exponent with either a radical with the same number as the index, okay, or with that number as the index, or a rational or fraction exponent with the number as the denominator in the fraction. Let's take a look at how this helps us. So graphing calculator limitations. Remember, I talked about this real quick, where the number of the index, we can't change it, okay? Not easily at least. So instead, we'll use a rational exponent, which is a fraction. Okay, so that means to cancel out the x to the 4th power, I'm going to do x to the 1/4 and to the 1/4. These two cancel out. That's the whole purpose of doing this. And right now, I'm just going to write out what I get. Okay, so this 81 is technically in there. I just don't like to write it again, but if I wrote it here, it'd be too small. So I'm giving myself some space, and that way I can see what happens. So I will now have x equals 81 to the 1/4 power. Now before we move into the final answer, I need to show you guys how to calculate this on your calculator. So I'm going to put it into your calculator. And what you're going to do is you're going to type in 81 to the power of, but you need to have 1 divided by 4 in parentheses. Okay, and this is really important. So if we put it in parentheses, notice I don't have to close it, I just have to have it start. That gives me 3. And I know 3 times 3 times 3, so let's check. 3 to the 4th power is 81. However, if I take away that parentheses, I get 20.25, which is not correct. Let's check that. So let's say 20.25 to the 4th power. That does not equal to 81. So what happened here is that we took 81 to the 1 power. Your calculator only knows that the 1 is part of the exponent. And then this divide by 4 just is dividing 81 by 4, which is not helpful and not correct. So we're going to use this as x equals 3. Okay. Let's do one more together, and then you guys are going to keep working with these. So to cancel out the x to the 3rd, we're going to take to the 1/3 power. Cancel out the 3, and we get x equals negative 343 to the 1/3 power, and that gives me x equals negative 7. I'll show you guys real quick how to type that in, just in case you need a second look. So we'll have negative 343 to the power of 1 divided by 3. You see it gets negative 7. Try that yourself on the calculator, please. It looks really easy when I'm doing it. But if you can't calculate it, it doesn't matter that you did all the work right. This answer here should be x equals 2. My answer key at the bottom is incorrect, so please change that to a 2. Okay, so now let us continue with example 2. It's just like solving equations in Algebra 1. The only difference is that we're now using rational exponents to cancel out these new larger exponents. So we are going to add 5 first. You see how those are stuck together? And then we're going to add 5 to both sides. The negative 5 and positive 5 has to cancel. And then we get x cubed equals 64. Cancel out the cubed by doing 1 to the 3rd power. 1 over 3. These two cancel. And we get x equals 4. Check that on your calculator to make sure that you agree that my answer is correct. Okay. These are for you to try. Be careful, there's an invisible plus in front of that 6. This one is still the same, but if you take a look, this is all stuck together right now, so I'm going to subtract my 7 first. Ooh, sorry about that. It's going to be 160. Now the number in front, hopefully you remember if it was just like 5x, we would divide by negative 5. So that's the same thing. We'll have x to the 5th power equals to negative 32. And then you're going to take the 5th root by doing to the 1/5 power. And we get x equals negative 2. Our last example is the most complex looking, but it's still the same idea. We're getting rid of things that are isolated, right? So notice this is all stuck together right now. So I'm going to subtract 6 first. Right now, the x minus 1 cubed is stuck together, so we're going to divide by negative 2 on both sides. That'll be positive 343. We're going to take the cube root, which is to the 1/3 power. So the cube root of 343, let's see, 343, oh, we did that here already, so it's very similar. Don't forget your parentheses. 7. And then the last thing we do is add 1 to both sides. And that gives us x equals 8. I would do at least one of each of these practice problems and then try your homework.